Good morning, everyone, and welcome to day 2 and our opening session, Network Connected Medical Devices, a Case Study. I'm your host, Mike McCune, Northwestern Regional Client Services Director here at CynergisTek. And before we get started, just as a reminder, there are a few housekeeping items. I know some of this was gone over in the earlier session, but I'll just go through them just as a reminder. On the right side panel of your screen, there is a communications panel. For any technical difficulties, use the chat tab and ask moderators any questions. And then we also encourage you throughout the presentation to use the Q&A tab to submit any questions ahead of time. Those questions will be addressed at the end of the presentation. And also, when slides are displayed, you can click the full screen by clicking the computer at the bottom right corner of the slides. Now to get started, next slide, please. I'd like to introduce to you one of the folks who was going to be on this, but unfortunately we had some scheduling issue that was unable to be here. So we will be presenting a use case that is based upon work done by Priya Upendra, Program Director and Quality and Compliance at Banner Health. Previous to Banner Health, Ms. Upendra handled clinical engineering and compliance and biomedical engineering at such prestigious places as Stanford Health and Intermountain Healthcare. As well, we have on our presentation, Shankar Somasundaram, Chief Executive Officer and founder of Asimily, a data-driven software company focused on medical device security. Asimily's solution provides continuous insights across a number of use cases based upon the device and its configuration within the environment and provides you with actionable recommendations. And then we will be having Carrie Whysall. Next slide, please. Carrie Whysall is the Director of Managed Security, where she's responsible for supporting and ensuring the managed security services, including our Managed Security Operations Center, Managed Vendor Security Program, and our Medical Device Security Program. Prior to CynergisTek, Ms. Whysall was with the National Security Director, dealing with the same subject matter as she is here at CynergisTek for Ascension Health, a 150-plus hospital nationwide system. So with that, I would like to hand the reins over to Carrie. And Carrie, please inform us of how you guys are going to be going through this case study and go through our agenda, please.
Great. Good morning, everybody. So Shankar and I are going to take you on a little journey with us through medical device security land. It's not really as fun as Candyland, and I guess if you really think about it, it's more kind of like Mousetrap. You're the one who doesn't want to get caught in a trap. However, we have a very short window of time here today. So you're going to notice that the slides have a lot of information on them. We're not going to go through and read every slide. We're going to try and take the highlights from each one. In the chat, there is a link to click so that you can download the slides and see anything that I missed talking about. So today we're going to really quickly cover medical device security services and challenges, effective risk management solutions, my personal favorite, vulnerability management, and then how to take the steps to apply those concepts. So let's start out with some of the medical device security challenges. I don't think anybody who's dealt with this area, these should be new to you, but in case you haven't, there are a few on here that people really don't think about as they're thinking about the challenges. We're all security folks. We kind of think technical. We probably shouldn't do that all the time, but hey, it's second nature, so we do. The big one on here is the culture. So there are lots of things that we can do technically to protect medical devices, but the culture is a big piece that we have to address. There's usually a lot of gaps between CE and IT. How do you get over them? What's the training? What's the knowledge? What does IT know? What does CE know? It's kind of a big gap. We all know about all the legacy stuff. The bigger one probably that we should talk about is how complex is your ecosystem? Do you have segmenting? Do you not? There's a lot of vendors. There's a lot of different levels of ownership across those platforms. And that usually is a place that you really get tripped up. Lack of tools. We know We can't scan these puppies. Every time we do, somebody screams, you take them down. So you end up with this great big gray list of devices you can't touch, and you really don't know anything about them. And then medical devices, and my favorite word when dealing with them, proprietary. They always have one little tweak to the operating system that makes it a little non-standard. They also typically won't let you run antivirus. And they also are collecting a whole lot of information that they don't tell us about. And sometimes they don't even tell us where they're sending that information. And then the last piece that I want to cover here is the dependencies. So there are a lot of communication dependencies that are going on. If you have GE or Siemens in your network, you might see communications out to the Netherlands and not know that you ever had to open a port to the Netherlands. Some of that stuff's normal, some of it's not. And how do you know when it's not normal? Let's talk a little bit about why we need medical device security. I'm sure anybody on this call that lived through WannaCry like I did, you already know the answer to that question. And we're hoping that we don't have another one. And probably shouldn't have said that without any wood to knock on, but let's talk about why. So we know that we're connecting these devices everywhere, and every day we add more connected devices to our networks. On the high end, we're probably somewhere between 10 to 15 connected beds. On the low end, we're probably somewhere between 3 to 6. But that's really, really a huge percentage of medical devices versus your normal IT devices, workstations, printers, scanners, all of that. So you're outnumbered by devices that you can't keep secure. The average number of vulnerabilities. And actually, when I read this, I kind of had to go back and look at it again. It seemed a little high to me, but actually it's low. And I've seen it anywhere estimated from the 6.2 up to 8.5. So it's not a pretty number either way you look at it. 60 to 60, I'd say 60 to 75% of the devices are unpatchable. And it's not that the operating system is unpatchable, it's that you can't get the vendor to agree to allow you to apply the patch. That is the big kicker. So we're not really saying you couldn't patch it, we're just saying you can't until. Most of your connected devices are unmanaged, and that's really because you don't know where they are. You might know that they're an IP address, you don't know who owns them, you don't know what's on them. CE knows a little bit about what's on them, but not a lot. There's a really high risk of breach with these devices, mostly because there's a lot of PHI that's being stored on them. And they typically are in departments that are not necessarily managed by IT. We all have that favorite term, shadow IT. A lot of these devices are in that group, and they're managed by those groups. And managed is probably a word I'm using loosely in that term. We all know that an attack can hurt us, and then we all know that it can damage our reputation. So how do you start taking a look at how to get to a better place for your medical devices? You really need to look at this as a program and not another tool. You can put another tool on the network and it will tell you information, but if you're not really getting a program developed, all you're going to do is continue bringing in devices and continue monitoring what's wrong while you're not fixing what's broken. So it's always a good idea for the first thing you do is to do a risk assessment. You want to take a look at what you've got, why do you have it, what can you do about it? The program is a little different. Do you even have a program? Do any of your policies, IT or otherwise, even mention medical device security? I'm going to bet that they don't. Then once you get a program created, how are you going to continue the management of that program? What needs to go into that? What pieces are you looking at? Some of these pieces we can talk about today. So the first one, risk assessment. There are 3 pieces that you really need to focus on for a risk assessment. First and foremost, your program. Where is it at? What do you have? Take a look at any documentation that you have. Look at remediation recommendations. Is there even a vague level of effort? Do you know? If not, put a program assessment together. Take a look at all the things that you can to develop your program. Your technical assessment, there's your tool. you need to get a passive scanning tool. You are never going to figure out where all these devices are using your traditional scanners. You're going to have to get a device, put it on SpanPort, take a look at what you've got. The bonus to that is that typically when we run this scanner, we find 10 to 15% more devices than were in your standard CMMS database. And that's a big deal. Nobody even knew the devices were connected to your network or what they were doing until you run that scan. Getting the rest of the security and network data. Why is this important? Today, if you go into your traditional CMMS database, you're going to get about this much information about your medical devices, and none of it is going to apply to the network piece. Most CMMSs are not looking at IP address, they're not looking at MAC address, they're definitely not looking at OS or patch level. So the tools can help you get that information then and help you figure out how to put it back together. Then the risk management strategy, you did those 2 assessments. What did you learn? What do you need to do? So you want to make sure that out of that technical assessment, you came out with a clear risk criteria identification. What are your device specific risks? And then really at the end of the day, what you wanted to get out of that was what's your recommended remediation plan. Once you have all that, you can start taking a look at how do you develop your program. And really, the program development piece is really just another word for life cycle management. You just need to know, what are you doing, how are you doing it, and how are you protecting it? That's really 3 pieces. How are you buying it? Once you buy it, how did you set it up? What are you doing for installation and inventory? And more importantly, what is your incident response plan? And what are you doing when you get rid of it? You got a lot of vendors that come in. You don't know that they took a device. You don't know that they wiped the device before they took it. You're not sure where it is until somebody buys it on eBay, and then everybody knows where it was. The one thing that you need to keep in mind, especially while you're doing all the assessments, is making sure that you're looking at all your risk factors. We always look at availability and unauthorized access. We're security people. It's what we do. Patient safety is what CE does. That's their only concern. Is the person attached to this device going to be safe at the end of this procedure? The one that we tend to forget the most is financial. How much will it cost if we lose this device? And it's not just money. How much will it cost our reputation if we have to defer patients from one of our facilities to someone else's facilities? It's probably not going to go well. And most of you who sat through the last big episode probably watched a lot of sites lose a lot of bonus points for PR. So just make sure that you're doing a well-rounded approach. How do you do that? Well, it's pretty easy if you follow this really quick roadmap. You've all seen it. We're all security folks. We know that we need to identify, detect, protect, respond. It's a little bit different for medical devices. And the reason that it is that last little blue box, containment and microsegmentation. This is a little different than how we normally treat our workstations. We look for a workstation VLAN, throw them all in. You might have a printer VLAN. You might have a medical device VLAN, but it's probably got a lot of stuff in it that it shouldn't have in it. And you need to start looking at microsegmentation. So it does have a little bit of a tweak there, but pretty standard if you're familiar with these processes. The one way that you can do that is by taking a multi-dimensional approach. You need to take a look at all of the things that are affecting this device. What are that device's relationship? How are you monitoring that device? What are you doing for remediation? Patch and mitigation prioritization is part of the puzzle, but it's really not one that's first and foremost like it would be in a server or a workstation environment. That's mostly because these devices, the manufacturers aren't allowing you to protect them. All right, so next, I'm going to turn it over to, that's my little timer for 10 minutes, so I didn't take all Shankar's time. I'm going to turn it over to Shankar, and he's going to talk to you about medical device vulnerability management.
Thanks, Carrie. Can you hear me okay?
Yep.
Okay, thank you. So Carrie actually set the groundwork for how you really look at medical devices, the differences, the inventory aspect, as well as the risk management piece, which was the last slide, which is a good segue into vulnerability management. Sorry, slide 18, which is a good segue. Can we go back to slide 18? We are on slide 9.
Trying to. There we go.
Yeah, so if you look at it, that's a good segue into vulnerability management. And the difference between medical and general IT devices is that in the world of IT, if you have a vulnerability, you're at risk and you look at the CVSS score and you determine what to do. But with medical devices, not all devices have the same risk. And that is true because even across devices with the same operating system, the same model, with the same software version, the risk could be significantly different. And the reason is in the world of healthcare, these medical devices, from what we have seen, are configured differently on the network. They're connected differently on the network. And they have different levels of PHI they store. They have different kinds of capabilities from the manufacturer. And they have different kinds of security controls. And all of this affect whether the vulnerability can be exploited, the impact on patient data or business. It does impact on whether you need to prioritize that. And then when you take into account all these factors, you actually realize that there's only a small segment of vulnerabilities that are really exploitable, that are really high risk, high impact. And when you find that, because like Carrie mentioned, many of them do not have a patch, you might have a workaround outside of simple segmentation and blocking that you can implement that can mitigate the risk posed by the vulnerability. And that's very unique to medical devices, which is not true of IT. Next slide. So here is a simple snapshot from a customer where we taken the GE ultrasound machine with the same model. Let me just expand my screen. The GE ultrasound Logic E9, which are running the same operating system, Windows Embedded 7 SP1, as you can see. And Windows 7 went end of life in Jan 2020, so early this year. Windows Embedded 7 went end of life even before that. And so you would expect that, and there are no real patches coming out. Some manufacturers are giving patches which are very expensive. And so you would expect all of them would be a high-risk device. But here we are showing an example from this customer where they have these Logic E9s, and you see the risk differing. It's going down from 7 to 6 to 4, even though it's the same manufacturer, model, operating system, same software version. And this is principally because even across the same model manufacturer, the way these devices are connected in the network, the kind of services ports they have open, how they are being used, the context of the device, the utilization of the device, all of those are different. And when you factor those into a comprehensive risk analysis, it turns out that some of these, even though they're running legacy operating systems, aren't really at risk. And that's very counterintuitive to the way you would look at it in IT. And this kind of analysis really helps you focus on the critical few, and then you can figure out what do you want to do with the ones which are high risk, which goes to the mitigation aspect, which we look at in the next slide. And so this drills down into one of those Logic E9s ultrasounds from this environment. I mean, we have masked out some of the fields. As you can see, the IP, MAC, hostname, similar to the previous field, the facility and the serial number, and all those fields are here. And here we have an example where there are a few vulnerabilities. So if you look at that, there's obviously a snapshot of the Asimily portal where it says number of high-risk CVs, which is what is there in this device. There are 11 high-risk Windows Embedded 7 CVs on this device. And you cannot go patch this device because maybe the patch isn't available. But it is saying that, okay, you cannot patch this device, but you can mitigate the risk posed by all 11 high-risk CVEs by blocking RDP on this device, or if you cannot do it on the device, by turning off RDP on the network so that the device cannot reach out using RDP. And so while that doesn't take care of patching the vulnerability, it does mitigate the risk posed by all 11 high-risk vulnerabilities, which allows you to continue to use this Logic E9, even though it's Windows Embedded 7, while lowering its risk. Next slide. And this is just drilling down into that one particular CVE. So we said there are 11 high-risk CVEs. This is just one of those high-risk CVEs. And this shows the description of the CVE, the configuration trigger, the exploit vector. The configuration trigger, exploit vector, and recommendations are all coming from the Asimily research. So Asimily does research on every vulnerability and we have research between 500,000 to 1 million vulnerabilities already. So all this is coming from our vulnerability research database, not just the vulnerability, but the research database. And then the rest of the CV parameters are combining everything Carrie mentioned, all the parameters, whether it's CV parameters, the connection, impacts, and everything. And then you're coming up with a list of CV parameters that is effectively telling you what is the priority, and then the mitigation tells you how you really want to focus. So this is a way to actually help you manage your vulnerability and focus on a critical few. So to mitigate your costs while reducing decommissioning costs, mitigating risk while reducing decommissioning costs, so you can continue to use your devices while lowering risk. Okay, Carrie, back to you.
Great. All right. Now let's take a look at how we can apply these concepts. Really, the biggest one is you need to identify in your organization what really are the drivers to get to a CE/IT convergence. There are a lot of reasons why you should do it, but making it happen can sometimes be a little bit more difficult. So a few points that you can hit when you're trying to make this happen is, we know, one, telehealth. Everybody's doing it. Everybody's nervous about it. These vendors typically probably got rushed in courtesy of COVID. They might have skipped your normal security assessments. Use it kind of as a driver to make it happen. We know that RFID is a big one as well. All of these points in here are reasons why you should do it. How you're going to do it is probably a little bit more difficult. The first way to do it is demonstrate that you have a problem. One area that we tend to forget about is could not locate. And the reason that it's such a big deal with these medical devices is they were connected. So does that device have PHI on it? A CE scan probably happens maybe twice a year, once every 6 months, depending on the type of device. You have state regulations, you have federal regulations, but they're really not looking at these devices commonly unless they're breaking. So in a typical device that gets seen twice a year, at that first 6-month mark, they're marking it could not locate. The second 6-month mark, we still could not locate it. You could have a full year before somebody says, hey, where is this device? Should it still be on our books? Should somebody be looking for it? In that year, it's probably left your facility. It's probably either taken apart for parts or sold back on my favorite space, eBay. I've never seen one on Craigslist, but I suppose it could be done. But you get what I'm getting at here. Could not locate is a great litmus test, because you can make the case that if you're using a tool to look for these devices, one of the pieces of that tool is that you can set a threshold and say, tell me when I haven't seen a device in 14 days, or when I haven't seen a device in 7 days. But a good litmus test is always how many are could not locate. My guess is when you pull that out of CMMS, it's going to be a much higher number than you would have ever expected. And usually on the IT side, we do a great job of stolen laptops, missing laptops. We need to get to that same due diligence with medical devices. Then you need to adopt a framework. Really, there's no way to say, here's how you do this. This is always going to be unique. We know that. There are a lot of things you need to take into account, and you really need to figure out how can you say what you're trying to say to your audience. It's going to be different from a large health system to a physician office to anything in between. So you need to know your audience. And when you're presenting that and adapting the framework that's going to work, you need to really take into account communication and training. So a lot of these folks today don't think medical devices are any kind of risk. They're just something that they do every day. Nurses, doctors, this is part of their life. It's how they treat their patients. We need to get them to the same level of awareness with medical devices as we work so hard to do with workstations. I know all of us, as we went through the HIPAA framework and be HIPAA smart and all of the training that we did to make sure people understand that anything they print, anytime they walk away from a screen that's not locked, all of that could have an impact on the safety of our data. They don't really apply that to medical devices. So it'll be your role to figure out how to get a framework to get that same level of attention to those details for the medical devices. And then really take a look at how do you develop that management solution? How do you develop your program? We know that these devices are high risk. We know that if one gets stolen, and this is a very key point here, you have to presume that you lost data if you don't know what's on that device. It's really no different than if you lose a laptop and you have to make a report to the OCR today. Luckily, we don't have to necessarily report the medical devices, but I bet it's coming. So we need to be ready for that same process for a missing medical device. And then really understanding where's the accountability for this. Today, I would bet there's no accountability because it's scattered all over your health system. But really, your CISO and your CEO are the folks who really need to have the accountability. They're also the people who manage the budget. So they're the people who can help fund getting this solution in place and really trying at least to get your hands on what you can do to mitigate this risk. Today, it's kind of an unknown, so you're not as wary or leery of what's out there because you don't know, you haven't taken a look. I guarantee after you run the first passive scan, the way you look at the risk for your medical devices will change. It's a big gap, and it's one that we're not really effectively addressing. All right, what were the key takeaways from today? We don't want to be in the mousetrap. You need to do an assessment. You need to find out what's out there. I know, it's scary. First time I saw the scan, believe me, I didn't sleep for about 3 nights, and that's saying something for me. Usually I can turn the cell phone off and get some winks, but it's an eye-opening event. And then talk about your remediation efforts. I think most people think that remediation is going to be a CE effort. And that's kind of when you're getting your CEIT convergence, that's a big gap. Clinical engineering is thinking, oh my God, I need 50 more people to do this work. IT is thinking, I have no idea what I'm supposed to do with these devices, but it's going to be clinical engineering's problem. I hate to tell you, but in most of the cases where we've gone through a remediation level of effort, it's about 90% IT. A lot of it has to do with managing how the devices are talking to the network. There is some CE work for sure. Any of the devices that are using generic passwords, which is pretty much every device that came out of the box and got put on your network, those will require manual touches. You'll probably schedule them during the PM efforts and make that a low remediation plan. But it really is a big deal for IT, and it's one that you guys need to be ready. Then once you've decided you think you're ready to look at this, just make sure that you pick a tool that really helps present your use case and really helps you get down that path of remediation. There's nothing worse than saying, hey, we have this great big problem, this tool can fix it, and then getting halfway through and finding out the tool can't. So do your due diligence when you're picking your tool. Partnership, again, I can't stress it enough. There has to be 50-50, 60-40, some kind of agreement between CE and IT, and it's a big gap today. We work well together, but we don't really think of each other as part of the same team. We need to fix that if we're going to have any chance at being successful for remediating these devices. And then lastly, don't sell yourself short. Make sure that the strategy that you're planning is going to live through the life cycle. If you consider this a program and not just you're putting in another tool, as you start building your policies, your procedures, your standards, your guidelines, all of that's going to feed into this being a program. At some point, you're probably going to set up some governance. You're going to have a steering committee over this. Really, as you start pulling the procurement pieces into this, it will start feeling more like a program. But as you're planning, you need to make sure that's kind of what you're doing. You want that 3 to 5 year look. You don't want the 1 to 3 year look because it's going to sell yourself short. You're going to end up trying to fix what's broken, but you're never going to stop the bleeding if you don't have a program in place to say, nope, as of today, this is how we're going to buy. We're not going to buy anything with Windows 7. We're not going to buy anything with Windows XP, and I can't believe I'm even saying that. But there are still devices coming onto the market today with Windows XP. So set your limits, work with your procurement people, deal with it as a long-term strategy. And I would like to thank you for your time today. Mike, I'll turn it back to you.
Excellent. We do have a few questions that came in through the chat. Let's see here. Our first question is, what do we do with legacy devices like Windows XP?
There's lots of things that you can do with Windows XP. Obviously, segmentation is step one. If they're already segmented, but unfortunately you have all of them in one segment, take a look and fix that. But one thing that we really had success with in the past is whitelisting. There are a lot of opportunities to use tools like Solid Core, although I think the name has changed now. But really what we did was put it on the devices, ran it for 2 weeks in monitor mode, looked at what that device needed for executables, and then basically blacklisted everything else. So there are options there. What you should be doing is looking what it's going to cost to replace those devices. But sometimes the ROI doesn't work if it's a big device like an ultrasound or a linear accelerator. They're not going to let you replace it. So you can whitelist it, you can segment it. That'll get you 95% of the way to being able to sleep again.
And if I can add to what Carrie mentioned some good points. The other thing to look at is, I think this is counterintuitive a little bit, but you might have an XP, but is it really posing a risk in your environment is a question you need to ask, right? And so you might have an XP, which is probably very tightly configured, which really only talks to a limited number of devices in your network, where the ports aren't open, as many ports aren't open, or the way it's connected is different, or the capabilities are different, or you have a proxy. So what you have to evaluate is, just because you have an XP, which has a number of vulnerabilities, maybe it's really not a risk in the environment, and the Windows 10 device that you thought is all updated and patched is really at risk. So you got to evaluate medical device risk is not just about the operating system. You got to evaluate it from a risk perspective, which goes back to the point Carrie mentioned about different dimensions on risk, that she had a slide on that, which you can go back and look at. And also the point I had mentioned, that there are a number of factors that actually play into the risk element in medical devices, unlike IT, which you account for. You realize maybe it's not a risk. And if it is a risk, maybe there's a workaround, like I had mentioned, that you can use to mitigate the risk. And if there is no workaround, then you can always do segmentation, blocking, whitelisting, and then long-term strategies replacement.
Excellent. Carrie mentioned ROI a few moments ago, and it kind of ties into one of the questions that we received, which was, how do you convince our management on the return of investment of implementing such a program as you guys have stated here today?
Oh my gosh, there are lots of ways to do that. And for me personally, being the person who had to meet with our cyber insurance folks once a year, that's a near and dear to my heart. Really, there are lots of ways to look at it, but probably the first thing that I would do is look at a real quick level of effort summary. So if you had to manually go out and touch every one of these devices, what would that cost? Do you know? And you don't know all the devices that are out there. So you're going to have to give yourself somewhere around the 10 to 15% swag. But high level, if you look at what it would take to manually make these devices safe versus bringing in a tool that would help you immediately see the level of risk that's in your network, that's a pretty simple one. Another feature of most of these tools is utilization as well. So there's a lot of ROI on that side as well, looking at how your devices are being used, where are they being used. We all know that every year there's a lot of capital dollars spent to replace equipment. If you could see how that equipment is being utilized every day and be able to say, well, we don't need 50 more infusion pumps. We just need, the 4th and 5th floors to take them out of the closet where they're hiding them so no one takes their equipment. It's a really powerful picture there as well. But I think the remediation level of effort probably carries a little more weight in that conversation.
Yeah. And add to what Carrie said, right? I mean, we actually had a couple of health systems who did a true ROI analysis where they actually collected quotes to do the analysis without a solution and a program and after a solution and a program, and they compared the two. And the way they did it is they actually looked at how much effort was it going to take for them to collect inventory, to do the vulnerability collection, to then prioritize it, to remediate it, and then the benefits from asset utilization on top of it. They found there was a vast difference. So if you actually take that stepwise approach and just say, and they have a few thousand medical devices, but you can just approximate how many man hours is it going to take per device to actually go collect that information, multiply it with the number of devices you have, and then what is the reduction in potential cost when you actually have a solution and a program that can effectively give you that information. And time and again, what we have seen, the ROI has been significant, even after accounting for the cost of the solution and the program. So clearly, Carrie and me, we could always offline give you more details on the exact steps you can do to present that ROI.
And our last question was, how do you interface with our existing systems like our CMMS system and ticketing systems?
Well, we'll let Shankar take most of this question, but all of the tools that we work with have either direct feeds or APIs. One thing that I would say about interfacing this with your CMMS tool, while it's a good idea, I personally prefer to focus on interfacing the tool with your CMDB first. Getting these devices into your CMDB allows you to make a faster decision at incident response time. When that phone call comes into your service desk, the first place they're going to go look is in your CMDB, and they're going to try to make the determination of where that call needs to go next. If you can at least get into your CMDB that these are medical devices and they need to follow that process, you're going to save yourself on average 20 to 30 minutes of investigating time. If they're not in there, all they've got is a department and the name of the device. Somebody's got to go hunt it down. Somebody's got to find ownership. So they all can talk to all of those systems. But for me, I prefer the CMDB, and pushing it to the CMMS or deciding which is the source of truth between the tool and the CMMS is always a plus. But to me, the CMDB should come first. But Shankar has done a ton of work with getting APIs and things set up to talk to CMMS systems. So I'll let him talk about that part.
Yeah, thanks, Carrie. So like Carrie mentioned, there are APIs that obviously we have developed with the CMMS, CMDB, and SIM systems to send the data and get the data back from them where required to kind of create a two-way path. And the two-way path might be required when you send inventory, when you actually create a work order, when you get information back from the work order and you have to close it. And a key point that Carrie mentioned is, how do you determine who's the source of truth? Is it the solution? Is it the CMDB or the CMMS? And at least what we have done at Asimily is we have a number of parameters like MAC address and serial number and IP where it's static, where we correlate the information across the two. And what we have done, at least with some of our partners, is gone above and beyond simple integration, where we have created separate queues where if the data is empty in the other system, we populate it, where if there is an existing piece of data already in the CMDB system and we find something that's different, then we put it in a queue that goes into approval, saying this is what Asimily generates and this is what the CMDB generates. So then the customer can validate it, and if they just want the Asimily solution to override it, they can say yes, otherwise they can leave the CMMS, the existing fields as they are. So we have gone above and beyond to solve some of these issues on data cleansing and matching the data. And there are a lot of little nuances here, like what if the manufacturers don't match, but they're acquired by one another, and a lot of simple issues that need to be solved. So we have gone above and beyond to solve some of these issues with our partners to address the data population in a way that is safe and still you get all the data.
Excellent. That is the last of the questions that we have from this session. So I will go ahead and release everybody at this time to head on over and take a 15-minute break. You can hop over to the one-on-one networking session where you can experience the speed dating business style, where you'll be able to randomly be matched with somebody else in the virtual room and have 3 minutes to introduce yourselves and chat for a few. At the end, if you'd like to share contact information with each other, then then that facilitates that as well. And then if networking isn't your thing, then feel free to meet us back here for our next session in 15 minutes. I appreciate everybody's participation, and thank you, Shankar. Thank you, Carrie, and everybody have a great day.
Thank
Thank
you.
you.